This series of videos concerns embedded systems design and programming, and how to do it with excellence, whether you're new to the discipline or a veteran. There's a corresponding series of articles available at AQDI.COM. This video is about defensive programming. Many embedded programs written these days do not run on naked micros, but run under some purchased operating system. That's good in that you don't have to write basic support services, but it can be bad when the OS is of inferior quality. The use of less reliable operating systems, such as Windows Mobile, requires very defensive programming practices so that your program runs without crashing and without killing the operating system. Windows Mobile is basically Windows NT, with 50% of the API calls deleted, seemingly at random. The operating system has memory leaks and security holes which are documented by Microsoft and other parties, and these things take years to fix if they are ever addressed. You have to live with this dumpster OS because this stuff is sold as quality merchandise at Best Buy. Programming on a poor OS is like driving through a crime-ridden inner city. I had an associate on a business trip in Miami. He was driving through on the freeway at night when he was directed to an exit by a detour sign. After a few blocks, the detour signs petered out and he was driving through the slums of Miami. He pulled over in a parking lot to ask a policeman for directions. The officer just said to him, "You do not want to be here." And then he repeated this several times, finally saying, "Follow me." The cop led him out of the area and back to the freeway. Unfortunately, with some OSs, you don't want to be there, but you cannot get away, so you have to arm yourself properly. Programming defensively involves not doing anything risky. Using API calls that have only been released in the latest version of the OS is usually a disaster. On a Java project, I would search for ways to accomplish a task and find several options, one of them usually being a recently added package. Every time I tried the new stuff, it did not work or would not compile. Sometimes I found that writing the code myself was the most reliable solution. Making an API call without some kind of hang prevention is risky, or at least logging what was happening so you can identify the hang after it occurs. Do you know that the timeouts on Microsoft's FTP function calls are broken? I searched for a solution to this and found complaints going back 10 years. I had to wrap each FTP function call in a thread so that I could kill it if the FTP site went down mid-transfer. In fact, it's best to use the least number of specialized API calls as is possible. I realize you might be limiting features, but if it's not specifically needed, leave it out. In an OS such as Windows Mobile, where the OEM configures available options, it's highly likely that some fancy features you're depending on will not be present on one or more platforms. This results in, surprise, your program's not being portable at best, and the cause of system crashes at worst. You need to understand that Microsoft has security and quality problems because of poor design and testing of OS components. Reduce your interaction with those components and your risk of failure goes down. But even if you program defensively, you will still have problems. For example, I had a customer experiencing data file corruption on a portable device. At one meeting, I joked with another guy about how the whole OS, down deep, was probably just making interrupt 21 hex calls. It's a DOS joke. We all laughed and then went on with the meeting. Sometime later, it was revealed that a vendor of the drivers for the media had not written them to be thread safe with long file names. I just about hyperventilated laughing about the previous DOS joke, DOS being single-threaded. Some idiot at the vendor copied some DOS code and did not even test it for thread safety. Their recommendation to us was to either shorten the file names or run all file accesses through one thread on the hardware. Do you know that many OS bugs are reported by users and news groups but are never fixed by the vendor? Just searching for a function name can reveal issues. If you're considering using a specialized API call instead of your own code, search for the name of the function along with words like bug, crash, not working, or the ever-useful sucks. You'll be surprised what you find. In many cases, the issue is not the function itself, but the lame documentation or non-functional examples, and other victims, users, can save you a load of time and nail-biting. But beware, because even their workarounds might be as problematic. Here are some other defensive activities. Check all parameters passed to functions, ranges for scalars, pointers, and array indices. Pass buffer links to functions and test them with every call. Check all messages sent between computers over a network. It's shocking to see code that parses UDP and TCP data streams with no length or error check fields and no data format parsing. They say, doesn't TCP do that? Maintain check codes on RAM-based data structures to detect corruption. Maintain software watchdog timers on threads and state machines to detect hangs and reset the system after logging the details. Have routines that check the general operation of the program, logging problems. Maintain an event log containing the date, time, priority code, source of the event, and event description. You need to program defensively against not just sloppy OS programmers, but those on your own team. If you're writing a subsection of code for your product, you need to hammer that baby until it's pure steel. There's nothing worse than getting a code module from another team member and finding that it's junk. Make sure that your work is only the best. If you're designing one end of a communication system, for example, be sure that you exercise your end of the link mercilessly before connecting it to the other party's code. You do this by creating a hardware interface and writing a test program that exercises your program as it will be used in the final system. Yes, that's a lot of work, but you end up doing it eventually, and it's easier to do with your test program than by staring at your counterpart's sloppy code loaded with go-tos and unreadable comment banners. Get your code working, then leave him in the lab over the weekend. And please understand that public documentation of APIs is only the start. You have to code to how the APIs actually work, as well as what the documentation says, always being aware that what the doc says and how it works may be two entirely different things. This is especially true with sockets programming, including Linux, and of course anything Windows. Understand that defensive programming is secure programming. Defensive programming is reliable programming. Program this way and your code will be better, and the benefits will trickle down to future systems as you hack that code into other functions that your customer needs. Our next video discusses interrupts.